Hi guys, and welcome to another video. This is topic 4, chemical changes, and we're looking at pH scale and neutralizations. Big shout out to Patreon subscriber Ploppy, great name, nice picture of a tank, much appreciated. And also hello to all my year 10s who are watching this during the coronavirus lockdown. So what we're looking at today is we're looking at everything to do with pH and neutralizations for the AQA GCSE course. So we're going to look at what ions are present in solutions of acid and alkalis. We're going to look at the difference between an alkali and a base. We're going to look at what the pH scale measures and how we can measure pH a little bit, and also what a neutralization reaction is and what's happening on a chemical level. Okay, so this is everything that you will need to know for the exams. So first step, what is a pH scale? Hopefully we've already got a really good idea of this from previous learning. We should know the colours, we should know the numbers, hopefully you see it in your labs whenever you have a science or a chemistry lesson. So, the pH scale measures the strength of an acid or an alkali. If you don't know that, now you do. And universal indicator can be used to detect what the pH of something is on the pH scale. And the range goes from 1 to 14, 1 being a strong acid, 14 being a strong alkali. So stronger the acid towards the left, starting from the neutral of 7, and stronger alkalis on the right. So around here we've obviously got weak alkalis, 9 and 10, and 6 and 5 are our weak acids. 7 is neutral, and it has to be exactly 7. And we should also be able to pick out the colours. So red is a strong acid, orangey yellow is a weak acid, green for neutral, a kind of a dark green to a light blue turquoise colour for our weak alkalis, going into our darker blues and purples for our strong alkalis. Okay, so little question for you, what is the pH of a strong acid? You should have answered 1 to 3, that's the kind of accepted answers. pH of a weak alkali, anywhere between 8 and 10, potentially 11 as well. Okay, there are some issues with using universal indicator, and I want you to have a little think now about what you think the problems could be with using universal indicator. And if you need a little bit of help, imagine you have been doing an experiment in school and you've been using universal indicator to measure the pH of something, and you've got the little card which has got the pH levels. What issues have you had in the past when you've been doing this in group work? Okay, the big issues are it can be hard to match up the colour with the scale. So it doesn't look like the colour for 3, it doesn't look like the colour for 4, it doesn't look like the colour for 5 really, it looks kind of like a mix between them. It can be very hard to read the pH, and sometimes you can get a range of about 3. So somebody might read it and say, oh, I think that's a pH of 8. Some people might say no, it's 9, some people might say it's 10, some people might still say it's 7, so it's difficult to read. So difficult people might disagree with what pH it shows. Little aside here, pH is a lowercase p and a capital H. The H represents hydrogen, so that is an element, so it always gets a capital H. We'll look at what the P means later. Solution to these issues is we can use a pH probe, and these are much better. So we'll have a look at a picture of one. There we go, that's a pH probe. So as we can see, it's got a little digital meter there that you can read off the pH, on-off button, a calibration button, and we've got some fancy electronic sensors down at the bottom. You basically dip it to about this kind of depth into the solution that you want to test and leave it there for a little bit, and it will give you a pH reading, and it will normally say like 1.23 or something like that for your pH. So the advantages, much more accurate and much more precise, and there's no individual interpretation of the colours, so that means the results are reproducible. If you think it's pH 4, it will definitely be pH 4. Somebody else will be able to do the same experiment and get the same result, unlike with the universal indicator when they might say it's 4 and you might say it's 5. So Next thing, what exactly are acids, alkalis, and this last thing called bases when we're looking at the chemistry? So, what makes a substance an acid or an alkali depends on what ions it forms when it dissolves in water. Now you should know from topic 2 that an ion is either an atom or a group of atoms that has an electronic charge on it, either positive or negative, and it's exactly the same with acids and alkalis. When acids dissolve in water, they release hydrogen ions or H plus ions. Okay, H plus ions. When alkalis dissolve in water, they release hydroxide ions or OH minus. So you'll notice acids H plus, alkalis OH minus, so oxygen, hydrogen minus. You'll also notice that a lot of alkalis have got hydroxide in their name. For example, sodium hydroxide, potassium hydroxide, lithium hydroxide are all alkalis, and they've all got hydroxide as part of their name. The last thing is what a base is. Now, really, an alkali is a type of a base. A base is basically the opposite of an acid. It can accept and bind to these hydrogen ions that are floating around. It can even rip the hydrogen ions off other molecules. An alkali is a base that dissolves in water, so it's soluble. Now, neutralisation reactions, you've probably all done these in class. You've mixed an acid or an alkali, mixed an acid and a base. There's loads of good ones. You can do a neutralisation reaction at home, get some baking powder and add some vinegar to it. That's a neutralisation reaction. It makes a volcano. You can also, if you've got a little film canister, you can make a rocket, which is quite good fun. So if you've got those little plastic film canisters, that's a really good way of amusing yourself during the lockdown period. So, acids and alkalis can cancel each other out, and that cancelling each other out means to neutralise each other. It doesn't necessarily mean, if I'm neutralising an acid, it doesn't necessarily mean I'm making the pH 7. If I'm starting off with a solution, it's got a pH 1, and I neutralise it, I can partially neutralise it and bring it, say, up to a pH of 3 or a pH of 4. Whenever we have a neutralisation reaction, though, we always make a salt and water. So the salt you put on your chips is sodium chloride. It's a type of salt, and you can make it in this kind of reaction. In fact, probably quite a lot of you have already done this. I know the classes that I teach will do this in year 7 and in year 9. We will make sodium chloride by mixing together hydrochloric acid and sodium hydroxide. But we can also show this reaction here through the ions that are involved. So if we remember, the acid gives us a H+, the alkali gives us an OH-, and if you've got H plus OH minus, and you combine those together, so the positive and the negative charge cancel out, and you've got H plus OH, or H2O, makes water. So this is what the ionic equation looks like, and you will be expected to know both of these things in the red boxes in the exam. So the things in the brackets, these are the state symbols. AQ means aqueous or dissolved in water. The L is a liquid. So water is not dissolved in water, water is the liquid that does the dissolving. So H plus is aqueous, it's dissolved in water, plus OH minus, aqueous, dissolved in water, makes H2O or water as a liquid. And you can see we've got 1H, 2H, 1O, 2 H's, 1O, it's balanced already. Easy. So, next thing we're going to do is look at how we name the salts formed in neutralisation reactions. And this is the same for a neutralisation reaction between an acid and a base, or an acid and an alkali. So the first part of the salt name is always a metal, or almost always a metal. So for example, sodium, magnesium, iron, copper. It can also be, though, sometimes ammonium, which obviously is not a metal. The second part, the name of the salt, because they come in two parts, comes from the acid that you've reacted with. For example, hydrochloric acid will give the second part chloride. Sulfuric acid will give the second part sulfate. Nitric acid will give the second part nitrate. So, if I was to take, say, plutonium hydroxide, and I was going to react plutonium hydroxide with all three of these acids, I would keep the plutonium part, which is my metal name, as the first part of my salt, and have plutonium, and then with hydrochloric acid would make plutonium chloride. Plutonium and sulfuric acid would make plutonium sulfate, and plutonium plus nitric acid will make plutonium nitrate. It's really, really simple. Also, quick note, on the sulfuric acid and the sulfate part, you may see this spelled as pH, which is the old or the British style, or you may see it spelt with an F instead of a PH, and that is the modern or the international way of spelling it. So both are correct, both will be accepted in the exam. So let's have a look at some examples of these then. I'm going to let you have a little go at these, but firstly we're going to do this top one together. So we've got sodium hydroxide. You can see all of these on the left hand side of the pluses. These are all hydroxides, these are all our bases, our alkalis. On the right we have our acids. So if we start with question 1, sodium hydroxide plus hydrochloric acid. It's going to make two things. It's always going to make water. So water will definitely be part of our answer. We're going to have plus water. Then we need the name of our salt. So we take the name of our metal. What's the name of our metal in question 1? Yep, sodium. And then if we go back and have a little look at what the acid gives us, so we've got hydrochloric acid, that's going to give us chloride. So the first one, we've got sodium, hydrochloric acid, chloride, plus water. Okay, you can pause the video now and try and answer these. I will put the answers in the comment section down below. Okay, summary. The pH scale is a way of measuring how acid or basic, in other words alkali, something is. The scale is from 1 to 14. 1 is a strong acid, 7 is neutral, 14 is a strong alkali. It's the H plus ions that make something acidic, and it's the OH minus ions that make something alkali. A neutralisation reaction between an alkali and an acid always makes salt and water, always. And the ionic equation for this is H plus aqueous plus OH minus aqueous makes water liquid. Okay. Please remember to like and subscribe. Leave your comments down below. If you've got any questions as well, leave those down below. Please share it as well with people you know who may find this useful, who are also doing GCSE in year 10 or even in year 11 who are looking to revise, although they have had their exams cancelled at the moment, so they may not find it so useful, but please share it, spread the word, please hit that subscribe button. It really does help. Okay, thank you very much guys, take care, and I'll see you in the next video.